Hi, in this video we're going to look at the topic of angles, and in particular we're going to look at some of the angle facts that you might need, mainly at foundation, but this is a really core skill, so if you're a higher candidate this might still be worth watching just to make sure that you can do all the things that we're going to look at in here. This video has been requested by Daisy from Bolsover School, so thank you for that. If anybody else would like me to do a particular video, contact me on Twitter at Mr_G_Walton or the school account at Tupton Maths. So what we're going to do in this particular video is we're going to look at calculating missing angles. Now this is a key word. You'll see this in the GCSE exam papers. If it says calculate, it doesn't mean measure with a protractor. You're going to have to use some angle facts to be able to work out what the missing angle is. And we're going to look at the following things: angles on a straight line, we're going to look at opposite angles, angles in triangles, and you might see some special triangles here as well, and angles formed by parallel lines, and another word, so this is a bit of literacy in this video, called a transversal. And what I mean by that is if these are your parallel lines here, denoted by the little arrows, that's something to look for, then the transversal is a line that crosses both of them, like this. And you'll see how some of these angles look like they are the same as each other. It's because they are the same as each other, and we're going to identify exactly why this angle is the same as this angle, and why the angle here is the same as this one, and why this angle here is the same as the one down here, and so on. And you're going to get some keywords to learn in order to describe why these angles are equal to each other. Okay, let's make a start then looking at example 1 here. This says that we've got some kind of triangle going on here. It says find angles A and B and give your reasons as to why they might be what they are. Now, when you're given two different letters A and B, and this isn't always the case, but I think it's a good top tip to think for, to look out for. Think about doing it in the order that your letters are given. So you should be able to typically work out A before working out B. Okay, let's have a look, see what we've got going on here. Now, if this were me, I wouldn't be worried too much about the whole picture. I'd just try and identify key parts of the diagram. So I'm going to see if I can use this, this special tool here. Okay, and so what we've got is just this little bit here that I'm pointing out with this laser. Okay, so I just want you to concentrate on this part and ignore everything up here. I know there's a triangle up there, but you don't need to worry about it. I just want you to pick and concentrate on this angle and this angle. Now, one of the things that you'll notice here is that actually these two angles look the same, and actually they are the same. We don't need to actually do anything in terms of measuring because we're calculating. We can say that this angle here is 50 degrees, and the reason that these are exactly the same as each other is because opposite angles are equal. So the reason is because opposite angles are equal. Okay, so we don't need to say anything else. We now know that A is 50 degrees. Okay, well, what else do we know? Now I'm going to encourage you not to worry about what's going down here, but think about the triangle. Okay, so ignore what's going on down here. We've got an angle. What else do we know about this triangle? Well, there's these funny lines here. I wonder if you know what these mean. I'm hoping you're saying yeah, or at least in your head you're saying yeah, I do want to know what these mean. It means that this length here is the same as this length here. It denotes a special sort of triangle called an isosceles triangle. Here it is, here's the word for it. It's isosceles. Now, an isosceles triangle has got some special features in that two of the lines are the same length, and also, in my picture here, the base angles are also equal to each other. Okay, so these two base angles down here are going to be the same as each other. Right, well, on my picture here, on the question, if we know one of these angles already, it's 50 degrees, which means that this one over here will also be 50 degrees. So we've got these two angles at 50. Now let's use another fact. Angles in a triangle add up to 180 degrees. So we've already got 50 and 50, which is 100, which means that angle B must be 80 degrees. So let's write it in. B is 80 degrees because base angles in isosceles triangle are equal. So 50 plus 50 equals 100. Angles in a triangle are 180 degrees. So you've got 180 minus 100, which equals 80. So 180 minus 100 is 80 degrees. Okay, so we've got angles in a triangle fact. We've got base angles in isosceles triangle fact. You will have enough space on yours to actually write all this in. I've just run out of space on my screen here, that's all. Okay. Let's take a look at this second example then. This time it says work out angle A and angle B, just like before. Something else to note on these questions is this one says not to scale. This is another warning really, more than anything else. It says don't try and measure this angle with your protractor. It will be wrong. Okay, so if it says work out angle A and B, it doesn't mean measure. If you're being asked to measure an angle with your protractor, it will clearly say measure. Okay, and this doesn't. Right, so again, let's see if we can ignore part of the triangle here. So I want you to ignore all of this, the bit that I'm cutting out with my Jedi tool here. I don't want any of this. All I want you to concentrate on is this part here. Okay, so this part is where we've got angles on a straight line. Okay, if I were to draw that out without anything else, we've got A and we've got 55 degrees. 55 degrees. And this is the only bit I'm interested in. Just this little bit here. The fact that it's made of a triangle is kind of irrelevant really. We're just interested in this bit. Now, angles on a straight line, I'm hoping you know, are 180 degrees. So we want to know what I can add to 55 to get to 180. So what's A got to be? And again, you can do it in one of two ways. You can either do 180 minus 55, or if you prefer to think, what can I add to 55 to get to 180? I'm hoping you're saying 125 degrees. Because, and this is the reason you're going to give, angles on a straight line add to 180 degrees. Okay, now we can start to concentrate on the rest of the question, which is the triangle here. Okay, we've already got a part of it. We've got 55, we've got 43. We just need to work out the rest of it. So let's go for 55 plus 43 is going to be 98 degrees. What do I need to add to 98 to get me to B? Well, to get me to 180. Well, I know that 90 plus 90 is 180. I've got 8 more here, so I need to take 8 away from 90, which is 82. You can do this in several ways. Again, you can do 180 minus 98. You will get the same answer of 82 degrees. Why? Well, because angles in a triangle add to 180 degrees. Okay, fairly straightforward. We've used a different fact though. We've used this one about angles on a straight line, even though on the face of it, it looks like it's something to do with this triangle. Okay, let's move on. Okay, this one, we've now got a pair of parallel lines. Now it actually says give a reason why AB, and this is interesting here, we're using the terminology for these letters. AB is the line going from A to B, is parallel to CD. So it's parallel to the line C to D. So if it was parallel, I could draw these little arrows in to show that they're parallel. Notice here I've got this line that cuts through them called a transversal. Okay, so let's see if we can give a reason why these are parallel. Well, let's note this and this angle here. Imagine I was walking along a road, I turn down another road, and then I come back this way. Let's see what kind of angle I've turned. I've gone along here, I've turned 140 degrees, I've turned 40 degrees back, I've done a 180 degree turn. So I'm coming back exactly the opposite way. Okay, well that means that I must have done, I must be coming back on a parallel line if I've done exactly 180 degrees, because I'm coming back exactly the opposite direction. And there's actually a reason for this, and these two angles here we say are co-interior angles. Another word for it is supplementary. In fact, these ones have a few words. Your teacher might have told you another one, but co-interior and supplementary are the ones that I use. Supplementary. I think that's how you spell it. And for these, it just means that they add to 180 degrees. So I'm not going to do anything else on this question, but I am going to start exploring these parallel lines with you a little bit more. I wonder if you can see another angle on here that is equal to 40 degrees. And I'm going to colour in all the angles that are equal to 40 degrees, and I'm going to colour them in a blue colour. So this one we knew was 40. Okay, I'm just going to colour it like this to start with. That's 40. Well, opposite angles we've seen before were 40. Is there anything else that's opposite 40? Well, no, there isn't. But there are other angles that look like they are also 40 degrees. Let's see. There's an angle here. How would I be able to tell that this is 40 degrees? Well, again, I've got an angle on a straight line. 140 and something. That's also got to be 40. And I've got another angle over here. Again, I can think about it, angles on a straight line coming up here. A part of it's 140. Another bit has to be 40 to make this straight line as well. So you'll notice that we've now got 3 parts of this picture which I can tell you are definitely 40 degrees, but for different reasons. Okay, let's start thinking about the reasons why these are 40 degrees then. This one here, you'll see, forms a Z shape, and this is something to look for. So if you see angles that form in this kind of Z shape, in the past we used to call them Z angles. They've actually got a proper word, which is the word that you need to use. So a Z angle, we say, is alternate. So if you were asked to identify what the angle up here was, you can comfortably say 40 degrees, and the reason you're going to give is this key word, that they are alternate. Okay, is there another one that we can see? Well, if we weren't asked for this one, and we were just asked for the angle up here, let's see what kind of shape I can form there. Now you have to use your imagination a little bit with these. I'm going to colour it in green. So down here, it forms a bit like an upside down F shape. Okay, and we can say that F shaped angle facts, if you like, or F shapes on our parallel lines are called corresponding. I'll give you some ideas about how you might remember these things in a minute, but alternate to the Z shapes, corresponding to the F shapes. And you might also spot another F shape, which I'm going to do in a slightly different colour again, just so you can see. So here, across here, and across here. Notice again we've got an F shape, and what I'm identifying are these bits here, like in the crux of these angles. These are also corresponding. Okay, so we've also got some yellow on there as well. Now these are all to do with just the 40-degree angle. You'll notice that the 140-degree angle also has these things as well. So if the 140-degree angle was red, notice down here is also 140. The reason being, again, I've got this F shape. It's corresponding. Where else is 140? 140 down here. Why? Because we've got like a Z shape again. It's alternate. And so on and so on. So we can identify all of the different parts of this for various reasons. There's so many reasons to do with why these angles have to be. We've got angles on a straight line. We've got opposite angles. We can say they're corresponding. We can say that they're alternate to each other. Lots and lots of different reasons. Okay, so let's think about how we can identify them and how we can remember. Co-interior angles look a bit like the letter C. That's fairly straightforward. These ones, though, take a little bit more thinking about. I know a colleague of mine uses the word zolternate to try and remember it, or foresponding. So foresponding. That's one way to try and remember that we're looking for these Z shapes and F shapes. I like to think of it being A for alternate is a Z shape, A to Z, and F shapes go with the word that starts with a C. So A to Z and FC. These are letters that come together all the time. A to Z like in the alphabet and FC like your football club. So lots of different ways to remember. Zolternate, corresponding, A to Z, FC. But the most important thing is that these are the key words you're going to use to give a reason why something is equal to each other. Or, in this case, why it adds to 180. Okay, I think we're about ready for you to have a go. Okay, here we go then. This is an exam question that says, in the diagram below, AB is parallel to CD. Here's AB. It's parallel to CD. You might be able to see on there that there's another reason why we know this, and that's because we've got these arrows marked on. They always show parallel lines. It says, complete the sentences below by giving reasons for the answers. 63 degrees. So it says, A is 63 degrees because something, and B is 45 degrees because something. So I want you to pick out what the key word's going to be able to describe these. Pause the video, have a go, and I'll tell you in a minute. Okay, so let's have a look. We've got, we're looking at A first. So A is here, and we've been told it's 63 degrees, which is here. Okay, is there a particular shape that I can make that kind of links these? Well, let's see. I'm colouring this one in red this time, here we go. It makes a Z shape. Which keyword identifies the Z shape? It's zolternate or alternate, A to Z. So A is 63 degrees because alternate angles are equal. Okay, let's look at the next one then. We're saying that B is 45. So again, let's identify 45. Let's pick a different colour. So here's 45, here's B. We've been told to try and give a reason why. Let's draw my lines in. There's a line, here's a line, here's a line. Oh look, we've got an F shape. Here it is. Here's my F shape. F shape ones, they're called corresponding, foresponding. So because corresponding angles are equal. Okay. Brilliant. If you got those right, really well done. This is a key thing to be able to push up towards those higher grades, being able to give a reason why, not just to be able to identify them. Okay, as ever, when we're doing some revision card notes, you might want to write down some of these ideas here. I'm going to draw myself a pair of parallel lines. and a transversal. Let's identify my parallel lines with arrows, just like you would be doing. I'm also going to draw myself an isosceles triangle, again using the correct notation, showing that these things down here are equal. So base angles equal. Base angles equal. And sides equal. Two sides equal, sorry. Let's think about what we know on our parallel lines. I'm going to colour in all the ones that are equal to each other. So this here is equal to that one because they're opposite. This one that I've just done is equal to the one up here because it forms a Z shape, so they're alternate. This one is also, so this one here is the one I'm pointing at, is also equal to this one up here for two reasons now. Number one, it's opposite this angle, and number two, it's corresponding to that one. So these angles are all the same. I'm going to choose a different colour and work out the rest. This angle and this angle are equal. This angle and this angle are equal. And this is always going to be the case. Okay? But what you need to be able to do is recognise the shapes as Y. And so what you need to be looking for are opposites, which form this kind of X shape, alternate, which form the Z shape, corresponding, which forms the F shape. Look for other angle facts as well, things like angles on a straight line. They might not be straight line in terms of a horizontal straight line, it could be a diagonal straight line like this, where the green and the red together add together to make 180. Or look for these supplementary or co-interior angles, C shapes, adding to 180. Look for angles in triangles, which add up to 180. And when you've got multiple things going on, don't worry about the entire picture, try and break it down into little bits, and always give reasons for everything that you write down. This is where you're going to pick up marks on these questions. Okay, I hope this has been useful. As ever, good luck in any exams, and if you need anything, get in touch. Bye!